Hello everyone, I'm with a new topic today. So I'm gonna show you how to do the Schlenk tube technique, new technique, freeze, pump, thaw method for your air sensitive reactions or like palladium catalyzed reactions, wherever you need to remove all kinds of air like oxygen. So uh, freeze pump thaw means like you will add all of your compound in a Schlenk tube and then close the cap tightly, connect that Schlenk tube arm with a vacuum line, and then in closed condition you will freeze your Schlenk tube in liquid nitrogen. So remember one thing, what is the basic idea here? With the liquid nitrogen, if you immersed it, so all of your liquid or solid, everything will solidify it because liquid nitrogen temperature is minus 190 degrees Celsius, minus 196 degrees Celsius actually. So it solidified everything, but the remaining gas, like if you have the air or oxygen, those will not solidified or like liquefied there, so that will be in gaseous form. So if you freeze it at that low temperature, and after that, in while your Schlenk tube is already in the liquid nitrogen, then you will open the cap, lose the cap, so that through the arm of the Schlenk tube the vacuum can suck out the gas. And that once, like, you have to keep it like 3 minutes or like 4 minutes, uh, while it is inside the like liquid nitrogen. You are going to see that in the video I'm going to show you. So once it is done 3 minutes or 4 minutes, then you will close the cap again, but your vacuum line should be on always, but you will close the cap again. And then once you are done with the closing cap, then you just take out your Schlenk tube and make it at a room temperature. You can use like water bath, then you can immerse it in the water bath, and it will take at least 15 to 20 minutes to come to the room temperature, as well as it will liquefy again all the reagents. And once it is like liquidified, then you can do the same cycle again, like then but while you are keeping it at room temperature, like bringing it back to the room temperature, you shouldn't open the cap or lose the cap, because in that case, because vacuum is already on with the double manifold system, so all of your liquid and everything will be gone. So be careful. And if you liquefy your Schlenk tube, and after that, if you in liquid nitrogen, if you do not open like to degas with the pump, and if you forget that to degas, and if you close it, um, um, and if you take it out, it can explode, so be careful. So normally, this cycle can be done 3 times. So every time you will just immerse in the liquid nitrogen, make the things everything solidified, and then slowly open the cap of the Schlenk tube to remove the gas with the vacuum pump. And once 3 minutes or 4 minutes is done, then close the cap again while it is in the liquid nitrogen, and then take it out and make it room temperature. So 3 times. Once third time is done, then turn the vacuum knob to the argon knob, argon gas. So, and then slowly open the cap and let um, pass gas for 2 minutes there. So once that gas pass is done, then close the cap again tightly, and then wipe out the outer surface of the Schlenk tube, and then you can put in a oil bath or like heating source, while you should have a like shield in front of the reaction system, and heat it up. If it is the heating reaction, heat it up for like overnight or like 8 or 12 hours. So let's see the video how someone is doing the Schlenk tube here. So I took the help from one of the grad student. So if you have any question, then you can ask me in the comment section. You can see the Schlenk tube already solvent and other things are taken. So now that Schlenk tube is connected with the vacuum line is on. So you are seeing that the whole tube is placing in a liquid nitrogen container, and it will be kept here at least 10 to 15 minutes until all the liquids and reagents become solidified. And remember, the arm of this Schlenk tube is connected with the black tube that is connected to the vacuum pump, and that vacuum pump line is already on. So here you can see like the system is taking solidifying at that liquid nitrogen. And be careful dealing with the liquid nitrogen because it is very low temperature liquid. And here this tube, this you can see this that line is on to the vacuum pump line. So but make sure that while this line is under vacuum, so the cap should be tight because cap shouldn't be on, sorry, cap shouldn't be like open. So this cap is closed right now and vacuum is on, and the whole system is getting solidified. So once it is solidified, then the cap will be opened while the tube is in the liquid nitrogen, that container. Now you are seeing that like the cap is loosened a little bit while it is in the liquid nitrogen. So that process, by this process, the vacuum is on. So it is sucking out all the air or oxygen from the system while it is at low temperature. So once it is like you can see the cap distance little bit loosened. So once it is done, then the cap will be tightened again to close to the completely, and after that it will be transferred to the like take transfer to the water system. Like it will be first taken to the you can see here like it is taking out from the liquid nitrogen. First the cap is tightened, and now it will be lifted from the liquid nitrogen, and it will be transferred to the water bath so that it can come to the room temperature. So he's just making sure that cap is tightened enough well so that it cannot suck out the things while it will be at room temperature. So degassed, and then you can close the cap again before taking out from the liquid nitrogen, and then you can keep it in a water bath for room temperature, and it will take at least 10 to 15 minutes, depends on the what are the solvent you use. If you are doing the Suzuki coupling and you have to use the water, then it will take more time to get it to liquidified. But if you use purely organic solvent, so it will be like less than 10 minutes, you can see the everything become liquidify. So once it is done, then you can see now still you can see the vacuum line is on, but the cap is closed in the Schlenk tube, and this double manifold is connected with the argon gas as well as the vacuum pump source. So here it is getting liquidified, and once it is done, you can see the color of the solution. It was actually solid while it was taking out from the liquid nitrogen container. Now you can see clearly it is getting liquidified. So once it is liquidified, then this whole system will be transferred to the liquid nitrogen container again for the second round. So here the whole system is lift up from the water, and now it will be immersed in the liquid nitrogen container again for the second round of the solidifying. And then once it is solidified after 5 minutes, then that black knob of the Schlenk tube will be loosened a little bit so that the vacuum can suck out all the air and oxygen from the system. So now this is immersed in the liquid nitrogen, and it will take at least 5 to 8 minutes to solidify the whole system except the gas, any remaining gas. So you can clearly seeing that you can see that the whole system is getting solidified here. The inside the glass tube, you can see the things are getting white. you can see this solidified, but do not keep it up for long time while it is solidifying without degassing. So now open this cap again, like lose it a little bit, and you can see the vacuum indicator, vacuum pump indicator is getting increasing. You can see here clearly it was like lower, now it is increasing. So it will come back again after 2-3 minutes or 5 minutes. So you can do, once you loosen it, you can do this at least 2-3 minutes and keep it 2-3 minutes. And then once that vacuum indicator coming back to its original position, you can see clearly here the cap is little bit loosened while the tube is connected with the arm, so it is sucking the vacuum. So now it is tightened again because now it will be changed to the room temperature or water system. So that's why you have to close the tube, and now it will be kept in the water again to thaw. This process is called thaw. So that's why the system is called freeze, pump, thaw. So that means first you freeze the system, then open the line with the pump, like use the vacuum. So that's why freeze, pump. Now this process is called thawing process, so making the room temperature. So that's why the whole system is called freeze, pump, thaw. So first freeze, then pump, use the pump, vacuum pump, and then thaw it. So this cycle will be 3 times. So once this is done, see, this is closed, the cap is closed while you are making at room temperature with the water bath. So this system is closed completely. So once your three cycle is done, then with the closed condition, then turn the knob of the double manifold from vacuum to the argon gas. While little bit high flow of argon is on, then you can slowly lose the cap so that the created vacuum is gone from the Schlenk tube and little bit gas can go inside. So like you can do it for 2 minutes. Once that 2 minutes is done, then you can close the cap again and wipe out the outer surface from the water and everything. Then you can start running the reaction at heating source. So this is the third cycle you are seeing that. So normally the people do 3 cycle of this freeze, pump, thaw method. So now again the whole system is getting cold to minus 190 degrees Celsius, so that the whole things can get solidified. You can see the change in the Schlenk tube, everything getting solidifying. So physical state is solid, getting solid now. So once that is solidified, then the gas will be degassed from this system with the vacuum, and then it will be transferred to water system again. Like after closing the cap, it will be transferred to the water to make it room temperature. And as I was discussing, so once 3 cycle is done, then you can close it and you can turn the knob to the argon flow and slowly put some argon gas. So here it is showing like how it is getting solidified, but it shouldn't be like out of liquid nitrogen for a long time, especially for the first time when before doing any degassing, because the basic principle is if you cool down the whole system including oxygen in it, and then without degassing, if you take it out from the liquid nitrogen, it will explode immediately because the gas cool down, and the gas can expand very quickly. So at if it lose the temperature, then it will expand very quickly and it will explode the whole system. So be careful while you are doing the freeze, pump, thaw process. So definitely while it is under liquid nitrogen, degas it, then close the cap, then you can take it out from the liquid nitrogen. Otherwise it can do explosion. And maximum time it is safe, but if you do any mistake, then it can do explosion. So yes, this was the video for today. So if you have any question of on this freeze pump thaw process, then you can ask me in the comment section, and I think this video will help you to understand and to do the freeze pump thaw process for any organometallic reaction, air sensitive reaction, palladium catalyzed reaction. Normally any palladium catalyzed reaction give like very good result if you do this process like freeze pump thaw process in the Schlenk tube. So many other reaction also, if you don't need to heat it up but still you need out of oxygen, so you can do the same process, or any other organometallic compound if you use, you can do, but I wouldn't recommend to do freeze pump thaw process with the like butyl lithium or like n butyl lithium, t butyl lithium, or any other this kind of things. You shouldn't do this, but mostly catalytic reaction, organometallic reaction, you can do this. So I hope this video will help you to learn, and if you don't subscribe my channel, please do it, and whoever already did, thank you very much, and bye now.